Example 6 is a quadratic equation, but the instructions say express your answer in a plus bi form, so you know you're going to get a complex number, an imaginary number for your solution. So don't even try to factor. Plug it in the quadratic formula, simplify, and there's the negative number under the radical. That's a good sign because you're looking for that right there. Now once you have the square root of a negative, you know that's imaginary. And the process would be to do these 3 steps. A negative number is -1 times a positive. Break it up into a square root times a square root. And then the square root of -1 is the imaginary unit I. But you know you can always do that. So when you're simplifying this, you can go right from the square root of a negative to I times the square root of a positive. And then you have to try to simplify the radical. So you look at perfect squares and see if any perfect square is a factor of this number. None of these are a factor of 39, so this is as simple as I can get. But now directions say break it up into a number plus an imaginary number. So this is the real part, and that's the imaginary part. So you have to take this fraction and make it 2 fractions. -5/4 and then I, radical 39/4. That's your solution. Number 7 is solving an exponential. For you guys who just got done with your other first review, that's awesome. Good job. If you haven't done that yet, you can do that. Please. But anyways, this is exponential because the variable is an exponent. To solve an exponential equation, the first thing you have to do is isolate the base with the exponent. Right? You have to divide by this coefficient. So I divide both sides by 87, and I get 68 point that number. Actually, I get that. So I wrote down most of it, ... but I'm going to use all of it. Okay? Now to here. And once you have the base raised to an exponent equals a number, you want to convert this to a log equation. So when you do a log, the first thing you do is look at the base. This one is a base e. Now e is the natural base, so you're going to use the natural log. The log base e is called natural log. It's used so much it has its own abbreviation, and there's a key on the calculator specifically for this. Okay. So what you know about logs is that the log base of some number has an output that's an exponent. So if you were to rearrange this into an exponential, it would be base raised to the exponent gives you the number. Base, exponent, number. So over here you have base exponent number. So to rearrange it into a log, the log base, your base is e. The number that was the result is 68 point that ... and the exponent that you have up here is 0.03x. I now have a log equation that I can solve. So if I just go back and do, just to get that number, 5918 divided by 87, I get that, and now I'm here, so I'm going to use the natural log key, which is down here. The natural log of that entire number. It's the last thing I did, so I'm going to use the answer command and see what I get. I get 4.21, all that right there. So that's equal to 0.03 times x. Divide both sides by 0.03. Get that. Go back up, round to the nearest thousands. Tens, hundreds, thousands. Look one place, that's a 5. So that becomes a 2. Good question. Let's see if I can get this guy in too. All right. That's 5 minutes. I'll stop. I don't want to make this too big.